Section 14.4, solving trig equations. We're going to start by verifying that something is a solution. So let's say we already are told that the answer is pi over 3. So the first thing we'll do is verify so that we understand what a solution means. Verify the given x value is a solution. And that's literally what your directions will say. So in this example, the equation that we supposedly are going to solve is 2 sine x minus root 3 equals 0. We have not yet talked about how to solve something like that. So let's say, for starters, let's say we're told that x equals pi over 3 is a solution, and we just need to verify that. Let's see how we would do that. So this is basically, you just take what you're told is the answer and you plug it in and you see if it works. So let's see if it works. So 2 times the sine of pi over 3, replace the x with pi over 3 minus root 3, and we're asking ourselves question, is that equal to 0? We're gonna find out. It'll be good review to evaluate this, is what we did in the last unit. So 2 is, we have to evaluate what is the sine of pi over 3. So at this point, I want you to be able to do it without the quadrant 1 is what you need to know of the unit circle. So let me see what this is what you would visualize. To find the sine of pi over 3, you're saying, what's the y coordinate at pi over 3? Well, where is pi over 3? Is that closest to the x-axis or further away? Because it's easy to confuse pi over 3 with pi over 6. Is it further away, or is it the one that's close? 1/3. It's further away. It's that one. So pi over 6 is close. That's 1/6. Pi over 3 is further away. So the coordinates, the one closest is root 3 over 2, 1/2. The other one is 1/2 root 3 over 2. And of course everything's positive in quadrant 1. So root 3 over 2 is the answer. That's the level of memorizing the unit circle that you do need. So you don't even need to pull out your calculator. So we're asking, is that equal to 0? Is our question. Well, 2 divided by 2 is 1. You get root 3 minus root 3, which sure enough is 0. So yes, we verified that is one solution. Now there very well may be, and there are more solutions, but we were just asked to verify. So we're getting there. So now let's say I'm asked find. Now we're going to actually solve ourselves. And what the directions will say is find the general solution. Find the general solution of the equation. So what does this general solution business mean? General solution. That just means find all possible answers. So you're going to use, because we can't list them forever and ever, you're going to have to use n, where n is an integer. N is 0, 1, 2, 3, 4, -1, -2. So, first example, let's solve 2 sine x plus 4 equals 5. Now we're going back to solve for x. So, hopefully your first intuition here is to isolate sine x. Just like you would do with a radical or anything else, is you would isolate it first. So you start with the furthest away, you get rid of that by subtracting 4, and you get rid of the 2. What's the opposite of multiply by 2? Good, divide by 2. So you get 2, first we subtract 4 from each side. At this level, we don't have to show minus 4, minus 4. Then you divide by 2, sine x equals 1/2. Okay, so that, you always have to get it down to your trig function. So you told me a little while ago that you would take the inverse sine of 1/2. Now, if you try to do this on your calculator, especially because I'm going to want, we always want our answer in radians if we're not told otherwise. If you even do that on your calculator, unless it's, you know, a special calculator, you're not going to get, first of all, if you even get one answer, you'd be lucky, and it'll probably be in decimal form, which is no good anyway. So what we do is we're going to say, where is the y-coordinate a half? Well, if you know just quadrant 1 of your unit circle well enough, you know that that happens right here, because you've memorized root 3 over 2 1/2 is the coordinates at, and where is that first angle in the unit circle? How many radians? The one that's closest to the x-axis? Pi over 6, right. So the answer here is pi over 6. That's part of it, plus the way you write this is, do you see that if you went around the unit circle a whole revolution, you would be at the same place again, right? So if I just added multiples of 2 pi to this, and I would, what's that called when you end up at the same place? Starts with a C. Yeah? Coterminal. Yeah, so you want to include all the coterminal angles, so 2n pi is what you would add. So it's that just takes care of everything. Every multiple of 2 pi that you can imagine. Now, there's one other missing piece here, and this is why solving trig equations is harder, is that there's another place where the y-coordinate is a half. Because of all the symmetry, where else is the y-coordinate a half? Which quadrant? Yeah, in quadrant 2. Do you guys see it's perfect symmetry, right? The coordinates here are negative root 3 over 2 1/2. Right? And the y-coordinate is still a half, because the y-coordinate is positive in quadrant 1 and 2. So you need that. So where is that? What is that angle in radians? It's totally symmetric, right? It's 1/6. This was pi over 6. 5 pi over 6, right? That's 1 pi over 6. So this is 5 pi over 6. Pi over 6 is the reference angle of 5 pi over 6. It's the same distance from the x-axis. So you also would need to say 5 pi over 6 plus 2n pi. And this is, that's your answer. Those are all the solutions. It didn't just say find one, it said find all of them, find the general solution. So any questions on one? We're going to do another example, of course. One more of this, except it's going to be tangent. Okay, we need to see more. So let's try. Let's say we have tan x minus 1 equals 0. Okay. So again, we want to solve for x. So the first thing you always do is isolate the trig function tan x by adding 1. So tan x equals 1. So, therefore, you can't divide both sides by tan. It just does not make any sense to separate the tan and the x go together. You cannot separate them. So x is the inverse tangent of 1. So this is review of the last unit. You have to ask yourself, where is the tangent 1 on my unit circle? When you divide the x and the y coordinate, where does that happen? It happens at pi over 4. Why? Because you do need to memorize quadrant 1, and the coordinates here are root 2 over 2, root 2 over 2. So when you divide sine over cosine, you get 1. And so the tangent's 1 at pi over 4. So that's the beginning of the answer. Pi over 4. But where else is the tangent 1? In quadrant 4, is it? Positive, negative? It's in quadrant 3, because a negative divided by a negative is a positive, right? The coordinates here are negative root 2 over 2, negative root 2 over 2. When you divide, you get 1. When you divide a negative by a negative, you get 1. Okay, so, and in fact, in every revolution, as we go around the circle, we'll have this answer, and then we'll have this answer, and then again this answer, and then this answer. So how do we say all of that using n in the most concise way possible? plus n pi, very good. Plus n pi, and that takes care of all of it because the distance from the first answer to the next answer is pi. You can all see that, right? It's 180 degrees, if you will, from here to here. It's a straight line is 180 degrees, which is pi radians. So every multiple of pi, you get an answer. So that's the general solution to the trig function.